Thank you for attending my poster presentation. My name is Elène, and I will be talking about my PhD research looking at how eastern chipmunks resolve the trade-off between exploration and exploitation. A common explanation for among individual differences in behavior are trade-offs between different levels of expression of the same behavior that result in similar fitness. For example, we can think of a risk-reward trade-off, where on one end, individuals tend to exploit known resources and may miss high reward opportunities, and on the other end, individuals tend to search for new resources that sometimes result in high rewards. However, individuals that may have lower rewards may also reduce their risk of mortality because of lower encounters with novelty and predators. Conversely, individuals that seek higher rewards might encounter higher mortality risks. Thus, individuals on both ends of this trade-off achieve similar fitness. When we specifically look at the trade-off between exploiting known resources and discovering new resources, we can also consider how these two activities are mutually exclusive, because an individual that is currently exploiting a resource cannot simultaneously be searching for a new one. In the population of eastern chipmunks that I am studying, previous work has demonstrated that there are individual differences in exploration behavior in a novel environment, as well as in daily activity, which are correlated in a way that supports an exploration-exploitation trade-off. However, how these behavioral differences relate to foraging behavior have not yet been established, and I am looking at whether we can detect a trade-off between exploration and exploitation during foraging, and whether there are individual differences in how this trade-off is expressed. My study relies on a population of chipmunks that is part of a long-term study in southern Quebec. Most of the individuals in the population are tagged with passive integrative transponder tags for individual recognition. For my study, I provided feeders filled with sunflower seeds with radio frequency identifier antenna to read individual pick tags to study exploration and exploitation from a foraging perspective. These feeders thus record the individual ID and time of visit of tagged chipmunks. This system was deployed on 2 sites where we provided only 300 grams of seeds every other day on one site, and where sunflower seeds were available ad libitum on the second. Furthermore, in this study population, we are able to determine individual burrows, which is important in a foraging context because chipmunks are central place foragers. Using this information, I quantified foraging behavior as a binary variable indicating a daily visit to a feeder as a function of the distance between the feeder and the burrow with individual random slopes and intercepts. When we plot the relationship between the probability of visiting a feeder and the distance between the burrow and feeder, we see an expected negative relationship between the two, because the probability of visiting a feeder decreases with increasing distance from the feeder. The 2 graphs represent the low and ad libitum food here, and every line represents the average daily response of an individual. In the low food condition, the repeatability of the behavior at the intercept was 13%. And it was 12% in the ad libitum condition. To assess the trade-off between exploration and exploitation, we calculated the among individual correlation between the intercept and the slope of this relationship, because we should expect that individuals that have a higher probability of visiting the nearest feeder cannot simultaneously be visiting feeders that are further away. And we found a strong negative correlation between the two in both contexts, indicating that individuals that have a higher probability than average of visiting the nearest feeder have a slope that is more strongly negative than average, meaning that the probability of visiting feeders further from the burrow drops off more rapidly. And we can see that this relationship was stronger in ad libitum conditions. Overall, our results support a trade-off between exploration and exploitation at the among individual level in chipmunks. The trade-off appeared especially strong in the high food site, which may be due to stronger competition for an abundant resource. What was surprising, however, is that we observed similar repeatability across sites. I expected there to be higher variance in the low food site compared to the high food site because the lack of food may force individuals to adopt different strategies, either explore or exploit, while in high food should lead to individuals with more similar behavior that tends towards exploitation. The lack of variance explained by individuals may arise because only individuals that are willing to use the feeders in the first place are detected, so we may be sampling a subset of the population that is more prone to using novel food sources. Thank you very much for listening to my presentation.